Hi folks, welcome to the first video in 3.3 where we're going to talk about two basic rules in probability, okay? And the two basic rules, we're actually going to explain them through this first example. And let me just highlight the rule before we talk about how to do them. So the first thing we're going to talk about is how do we find the probability that two things are going to happen together? So probability of B and D. And then secondly, we're going to talk about this case of or. What happens if we only want to consider the probability of B or D, okay? And we're going to use this to introduce a couple formulas. So let's take a look. A student goes to the library. Let event B, the student checks out a book, and D, the student checks out a DVD. Suppose that, like before, the probability of B is 0.4, probability of D is 0.3, and the probability of D given B is 0.5, right? So let's take a look at this first, part A, okay? And so to find the probability of two things happening, right, we have to use the following formula, right? So the probability of D given B is going to be equal to the probability of B and D divided by the probability of that second one of B, okay? And let's plug in the numbers that we have so far and see how we can solve for what we want, okay? And so in this case, I notice that I have the probability of B given D is 0.5, and the probability of B is 0.4. And so that means that I can find the probability of B given D since I know the other two numbers in here, okay? And so let's fill in what we have. I've got the probability of D given B is 0.5 equals probability of B and D, and then divided by probability of B, which is 0.4. And so if I multiply the 0.4 to both sides, I'll get the probability of B and D is going to equal 0.5 times 0.4, which gives us 0.2, okay? And so we use this formula because it has B and D, and it has part of that information that we want, okay? Now let's take a look at part B, find B or D, okay? So notice in particular that now we're using a different word here. We're using or instead of and, okay? And I'll do that sort of in the light purple. All right, so to find the probability of something or something else, we have a formula for that, okay? The probability of B or D is going to be equal to the probability of B alone minus plus the probability of D alone minus the probability of B and D happening together, okay? And sort of as a short explanation of why we have this minus piece here, it's because we don't want to double count the things we already counted, like the books got checked out and the DVDs get checked out. So we basically want to make sure we cancel out any of the people who maybe checked out both of them and then therefore get double counted. Okay, so I think we have all the information we need. So P of B is 0.4 plus P of D is 0.3 minus, well, we just found P of B and D in the previous part. So that's our 0.2. And if we put that into our calculator, 0.4 plus 0.3 minus 0.2, well, that will give us 0.5. Okay. And so that's sort of a good example to start out this section 3.3 with, where we talk about the difference between and or, okay? And while we're here, I want to go over sort of like another example that talks about some of the things we've already talked about, but like sort of brings it up together and maybe is a good reminder on some of the things from section 3.2, okay? So if we're talking about the same library question, a student goes to the library, let B be the number of students that check out a book and D be the students that check out a DVD, and we're given the same information, okay? And so you'll notice here that we've got, for part A, P of B prime, okay? And just as a reminder, the prime means the probability of B not happening, okay? And so the way we find that, it would be good to remind ourselves that the probability of something happening plus the probability of it not happening will equal 1. Always, always, okay? So either it happens or it doesn't. And so together we have 100% chance that either it's going to happen or it's not going to happen. And if I plug in the numbers that I have, I notice that for P of B, I can put a 0.4 plus P of B prime is what I'm looking for equals 1. And how do I get this P of B prime by itself? Well, I just take that 0.4 and I subtract it to the other side. And so that'll give me P of B prime will be equal to 1 minus 0.4 or 0.6. Okay. All right, now let's take a look at part B. All right, part B says P of D and B. All right. And one thing I want to make clear, in case I haven't earlier, is that when we have our and, that the order isn't gonna matter. Okay, in other words, this is the same as probability of B and D happening. Okay. And if we go back up to our previous example, we actually found P of B and D to be 0.2, which means P of D and B is also 0.2, okay? So from above, we know this is going to be 0.2. All right, let's take a look at C. It says find P of B given D, okay? Now, earlier, I noticed that they gave us probability of D given B, but we can't assume that this one is the same. Okay, so in this case, order does matter. And in fact, I have to go back to that equation that says probability of B and D divided by probability of that second one of D, okay? And if we plug in the numbers we have, we're gonna have 0.2 divided by, let's see, probability of D is 0.3. And so we end up with a probability of 0.67, okay? And so we can see that this is different from finding probability of D given B. So when we change the order, we actually get a different answer, okay? All right, let's take a look at D. We've got probability of D and B prime, okay? And so one thing to note is that when we're thinking about our complements, as we talked about above, we said that probability of B plus probability of B prime is equal to 1. Well, it turns out we can sort of extend this and say probability of D and B plus the probability of D and B prime should equal the probability of just D happening, okay? So effectively, either B happens or B doesn't happen, it doesn't really matter. At the end of the day, it should be equal to the probability of D happening, okay? And so let's plug in the numbers we have. So probability of D and B I have is 0.2 plus the probability of D and B prime equals probability of D, which is 0.3. And all I'm going to do is just subtract that 0.2 to the other side, and I get that probability of B plus, or D plus B prime is 0.1. Okay, so a little bit of an extension from part A. But last but not least, let's go ahead and find probability of D given B prime, okay? And when we're finding that in part E, we're just going to use, let me go too far out. We're still going to use this formula, but the order that we put the letters just need to match the formula, okay? And so this will give us the probability of D and B prime over the probability of the second one, the given one, B prime. And if we do this, we actually found a lot of these answers so far, okay? We found that the probability of D and B prime is 0.1, and the probability of just B prime is 0.6. And so I get 0.1 divided by 0.6, which should give me a probability of 0.167. Okay, so let me get this all on one page for you. All right, and I'm going to come on back because I'm going to do a second video just with more examples from 3.3. Okay, thanks so much.